So I just wanted to go through some graphs before we get to doing some real problems. So, I don't know, think in your head for a second. What do you think the limit as x goes to a of this function f of x is? And f of x is x squared. Here. Think for a second. You just plug in a for x squared, because x squared is continuous everywhere and it's not a piecewise function. It's like a what you see is what you get function. And whatever a is, well, the limit will just be a squared. Alright, now we move on to another one. Alright, so I want you to think for a second what you think the limit as x goes to a of this function is. Pretty much I have two different choices, and stop and think. And the answer is C, right here. Why? Because, you know, if you were to go here, 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 it goes to C. It doesn't really matter that f of a is b. The limit of f of x as x goes to a is c. Because that's what our definition of a limit is as the function is traveling, where is it going, not where it winds up. Because those are two different questions. So you need to make sure that you understand which ones is being answered or being asked. Alright, moving on. Let's try this one. I kind of went over this, but, you know, do it for, you know, so from the left, the limit as x goes to a to the left of f of x equals c, right here. But over here, the limit as x goes to a to the right is b. And, well, b is not c, so the limit as x goes to a of f of x does not exist. Alright. And here, again, what's the limit as x goes to a? Right here of f of x. Well, you trace it, and oh no, it keeps going. There is no limit, so it doesn't exist. Alright, those are all the graphs. Alright, so here I have a problem, and it's asking you to compute the limit as x goes to 2 of this function x squared minus 4 over x minus 2. So the first thing I think you should think about is, what is the domain of this function? Well, I see there's an x minus 2 here. We know the denominator can't be 0, so there must be a hole at x equals 2, which means that x cannot be equal to 2. It's not bounded by anything else, so as far as we know, the domain is just negative infinity 2, unite with 2, infinity. So, now that we know that, well, if the only discontinuity is that x equals 2, well, this should have a limit, because there's no reason why it couldn't. So let's try to figure it out. Well, we see this and we think, maybe I can factor that out, because we know any a squared minus b squared can be written as a plus b multiplied by a minus b. So let's do that with x squared. So we can write this as, x plus 2 times x minus 2 over x minus 2. We can cancel these two out to get the limit as x goes to 2 of x plus 2, which is really easy to compute because we can just say, well, it's 2 plus 2, which is just 4. So the limit of this big thing in the end is just 4. Alright, so let's move on to something else. Here we have a piecewise function. All right, our piecewise function. So we have three things going on right now, and our question is, what is the limit as x goes to 2? Okay, well, first we should, because this is a piecewise function, there's a lot of things going on, we need to think about, okay, we need to find the limit as x goes to 2 from the left, and the limit as x goes to 2 from the right. Well, from the left here, oh my god, that's going to be anything that where x is less than 2, and the right is going to be anything where x is greater than 2. So let's find the limit as x goes to 2 of x over 2 right here. Just taking that. Well, that's just 2 over 2, which is just 1. So the limit as x goes to 2 from the left of h of x is just 1. Alright, so now let's compute. Oh my god. Compute from the right. That's just going to be the limit as x goes to 2 of 3 minus x. Okay, well, that's just plugging this in for x. It's just going to be 3 minus 2, which equals to 1. So limit as x goes to 2 from the right is, of h of x, is 1. And these two are the same, so the limit as x goes to 2 in general is just 1. So again, it doesn't matter that h of 2 is 3. The limit as you come from the left of the function and the limit as you come to the right both converge to the same number, 1. And that's the question that we're asking. So yeah. Alright, let's try something a little harder.